welcome to the Lesson 3.3b podcast. By the end of this podcast, as a student, you'll be able to both solve exponential equations and solve logarithmic equations. All right, so we'll start with solving exponential equations. We have some steps here. Pretty much for whether we're solving exponential or solving logarithmic equations, you're going to want to start by isolating your exponential expression. So what that means is the exponential expression is the base to the x power. So it'll usually be some number here, so maybe 4 or 3 or 2 or 5 or anything, raised to some power involving your variable that you're trying to solve for. That's what makes an equation exponential. So after you do that, so if looking at this example here, we want to start by isolating our exponential expression. Well, our exponential expression here is 5 to the x power. So we want to start by getting rid of this 6. So we can divide both sides by 6, and we get 47 divided by 6. You can leave it like that, 47 over 6 equals 5 to the x. All right, now we've got to get rid of this base. Well, the way we do it is we take the common log, which is log base 10, of each side of the equation. So the only time you won't take the common log is when your base is e rather than any other number. Then you can take the natural log of each side. We'll deal with that in a minute. So we're going to take the common log of each side. We're going to say log of 5 to the x equals log of 47 over 6. So now that we've taken the log of each side, we can use properties, i.e. the power rule, to simplify and solve for the unknown variable. So the whole point of taking the log of each side after we've isolated our exponential expression is that whatever our exponent is can come out front due to that power rule. So we've got x times log of 5 equals log of 47 over 6. And then to solve for x, we use our calculators. We're going to divide by log 5. It's going to cancel that out. It equals 1. So x is going to equal log of 47 over 6 divided by log 5. So practice entering this into your calculator, and you should get log of 47 over 6 divided by log 5. And remember, the log button is in the bottom left corner of your calculator. You should get 1.28, 1.278. So 1.28 would be the correct answer here. So x equals 1.28. Okay, so that is how we solve for this. All right, next, we've got -3. We've got -3 times 10 to the 4x minus 6 plus 10 equals -90. Let's do that one next. Let's do this one next. So notice we have a base of e here, so we know we're going to use the natural log when the time is right for that. But we've also got to isolate our exponential expression. So isolating e to the x plus 2, I add 3 to each side. I get e to the x plus 2 equals 23. And then I divide, and then now that I have this isolated, I'm going to take, rather than the common log, I take the natural log of each side. So I've got natural log of e to the x squared equals natural log 23. And our x plus 2 is going to come out front. So we've got x plus 2 times natural log e equals natural log 23. And we remember natural log of e is 1 because this is log base e of e. That cancels out. You could divide by this and enter it in the calculator, and natural log of e wouldn't matter either way. Then we've got x plus 2 equals natural log 23. Then we subtract 2. So we're going to do whatever the natural log of 23 is minus 2. So we enter this into our calculator. Natural log 23 is 3.13, and then we subtract 2 from that, or 3.14. So we got 3.14 minus 2, so x equals 1.14. That's our final answer. All right, Finally, we're solving for x here. This one's a little more complicated, but still the same idea. All about isolating this exponential expression right here. So this is negative 3 times something plus 10 equals negative 90. We're trying to isolate what's in the green box there. So when we do that, we're first going to want to subtract 10. So subtract 10 from each side. So we've got negative 3 times the stuff in the green box equals negative 100. Divide by negative 3. I've got 10 to the 4x minus 6 equals 100 over 3. And now I'm going to take the common log of each side, because remember, we're not dealing with base e, we're dealing with base 10. So we log each side. So I've got log of 10 to the 4x minus 6 equals log of 100 over 3. And now I can bring my coefficient out front, or my exponent out front, do the power rule. For 4x minus 6 times log 10. So we got 4x minus 6 equals, remember I got to divide by log 10 here. Divide by log 10. Use the calculator to get an expression for this. So I've got log of 100 over 3 divided by log 10. So I got 1.52. So 1.52, that's what this is equal to. So we got 1.52. And now we just solve for x. So we add 6, 4x equals 7.52, and then divide by 4. And we get 7.52 divided by 4. And we get 1.88. So x equals 1.88. And that is our answer. All right, now it's your turn to try some. So pause the video, and be ready to review your answer when you unpause. All right, so hopefully you've tried this problem and you're ready to give it a go. So first, we want to isolate this. We want to start by adding 6 to each side. So we've got 12 to the x equals 74. And now remember, once it's isolated, we take the log of each side. So we got log of 12 to the x equals log of 74. Bring my x out front. So I've got x times log 12 equals log 74. Remember, log 12 is a thing, so I got to divide by log 12. And that is how I solve for x. Log 74 over log 12. We enter that into our calculator. Log 74 divided by log 12. We get 1.73. So x equals 1.73. And that's rounding to the nearest hundredth. So with this second problem, again, it's a little more complicated, but not terribly much so. We're looking to isolate this exponential expression, e to the power of 6 minus 2r. We're solving for r. So I'm going to start by subtracting 1 from each side, and then dividing by 10. So we're going to have 10 e to the 6 minus 2r equals 44.9. We divide by 10. So I have e to the 6 minus 2r equals 4.49. And since our base is e, it makes sense to take the natural log of each side rather than the common log. Makes life a little easier for us. So take the natural log of each side. Our 6 minus 2r comes out front. That's the whole point of logging each side. So 6 minus 2r comes out front. So that's gone. And now, since I've got 6 minus 2r times natural log e, well, natural log e cancels out as well. So now I can say 6 minus 2r equals natural log of 4.49. I can get the decimal approximation for natural log of 4.49, which is natural log 4.49, and we get 1.50. 1.50. So I get this equals 1.50 equals 6 minus 2r. Now we can solve for r. So we're going to subtract 6. Negative 2r equals negative 4.5. Divide by negative 2. We get r equals 2.25. And that's our final answer. Okay, so solving logarithmic equations, you're going to run into two types of logarithmic equations. One where there's a log on both sides of the equation, where the steps here are shown. Notice how for this problem we've got log and log. Here we have logs and logs. On this side over here, you have logs on just one side of the equation. So here we have logs just on the left side. Here we have logs just on the left side. That's the basic idea. We have two different approaches based on each. So you want to start by making sure each side of the equation is expressed as a single logarithm. And if they're not, you must condense that side that's not. So here, we already have each side as a single logarithm, so we don't need to worry about condensing. Let's go ahead and solve this one. So once we realize that, we say, or once we confirm that, we drop the log on each side, setting the arguments equal to each other. So we know that 3x has to equal 4x minus 10. So we say 3x equals 4x minus 10, and we solve for x like any linear equation. So subtract 4x, get negative x equals negative 10, divide by negative 1, we get x equals 10. So easy peasy there. Now for this one, same idea. We still have logs on both sides, so we're going to have to use these steps. But we want to make sure again that each side expresses a single log. Well, this side is not. But this side can be condensed like we did last lesson. So remember, when we have log of something minus log of something else, you can condense these into a single logarithm. We can write these as log of, remember, anything that's positive goes up top, so 3x up top. On bottom, we have the 2. So we have log of 3x over 2 equals log of 9. Now, since we have it down to a single log on each side, we can go on to step 2, drop our logs, then solve for x. So 3x over 2 equals 9, setting our arguments equal to each other. Multiply by 2, 3x equals 18, divide by 3, and we get x equals 6. So that's the difference between ones where we don't have to condense with logs on both sides and ones where we do have to condense with logs on both sides. All right, let's look at where logs are just on one side of the equation. So the difference when there's logs on one side of the equation, rather than just dropping the logs as we were able to do here, what you're going to have to do is rewrite it in exponential form once we isolate our log expression on each side. So we want to start by isolating the logarithmic expression. Well, remember, the logarithmic expression is the log base whatever of the argument. So this right here is our logarithmic expression. So we want to start by subtracting 1. Get rid of that 1 right there. So we get rid of the 1. So we have log base 5 of x equals negative 1. Well, once this is isolated, which it is, we now rewrite our equation in exponential form. So remember, when we do that, the steps were identify the base, swoop it, and then rewrite the other type of equation on the other side, or expression. So here's our base, it's 5. We swoop it over here. We rewrite the right side as 5 to the negative first power. Remember, that's the base, that's the base. Bases have to stay the same. And then we remove the log's base, the log's gone. So we have x equals 5 to the negative first. And then we know that that's 1/5, 1 over 5 to the first power, or we can use your calculator and get x equals 1/5. So that's how we solve when there's a log on just one side. Let's practice one where you have to condense a log on one side. So notice how we have logs just on the left side of the equation. Here's our equal sign. No logs over here on the right. So we only have logs on the left. So we have to isolate the logarithmic expression, and you may need to condense. So this we do have to condense. We have to write this as a single log. So kind of like we did over here, but these are added. So when we condense them, it'll be log base 6 of 5 times x equals 1. Okay, well now that we have our expression isolated, we can now rewrite our equation in exponential form. So bring our 6, swoop it, make it 6 to the first power equals 5x. And now that's 6, so we can just divide by 5. So x equals 1.2. And we're done. So that's the basic idea. You can say 6/5 or 1.2. All right, let's practice a couple more solving logs. Okay, So when we're solving logs, we always have to decide what's our approach. Is it log equals log, where logs are on both sides? Or is it logs equal a constant, where there's only logs on one side of the equation? So looking at this one, I see, well, here we've got multiple logs, so it kind of starts to make me think that we've got log equals log, but based on where the equal sign is, we only have logs on the left side of our equation. So it's actually a log equals a constant. That's what this one is. So we're going to have to condense. So let's condense this down. I've got, well, this is subtracted. I got natural log of, remember positive ones go up top, so it'd be 4 up top, minus, so the x plus 3 goes on bottom. I've got 3 over here. Okay, so, all right, this is a little tricky because it's natural log. Now we would be identifying our base, but we don't have a base. So if you remember, natural log, its definition is that it's log base e. So we have essentially log base e, 4 over x plus 3 equals 3. So now I know my base, so I can swoop it. So swoop our base, rewrite it as e to the third on the right side. Log goes away when we swoop its base, equals 4 over x plus 3. All right, so we have e to the third. We're going to need our calculator for that. You hit second natural log to find that. E to the third power is 20.09, 20.085. So I'm going to plug 20.09 in here. So 20.09 equals 4 over x plus 3. And now when we're trying to solve for x like that, it's a little tricky because the x is in the denominator. Whenever the x is in the denominator, you want to start by multiplying it out of there. So we're going to multiply by x plus 3 on each side. So the x plus 3's cancel out of the left side. So we got 4 equals, let's distribute this in, 20.09x. You wouldn't have to distribute actually. So you could distribute though. Whoops. So you could distribute, but you don't have to. It's actually easier if you were, instead of, so we have 20.09 times x plus 3. You could divide by 20.09 on each side. And you'd have x plus 3 left here. So 4 over 20.09. So we have 4 over 20.09. We'll see what that is. 4 divided by 20.09. And we get 0.199. So 0.199 equals x plus 3. Subtract 3. And we essentially get 2.8. Negative 2.8 equals x. And that is our answer for x. All right, last one here before you try one on your own. So here we go. So again, we're deciding, is it log equals log or is it log equals constant? All right, here's our equal sign right there. And I've got logs on both sides. And so I look at, okay, are my logs, is it already written as a single log on each side? And yes, it is. I got log base 6 of x equals log base 6 of this stuff, 2x minus 18. So I can go ahead and go to step 2 and drop my logs. So I set the arguments equal to each other. X equals 2x minus 18. Solve for x. So I'm subtracting 2x. I get negative 1x, or negative x equals negative 18. Divide by negative 1, and I get x equals 18. And there we go. All right. Last slide. Now let's pause the video and please attempt the problems below. Unpause when you're ready to check your answer. All right, hopefully you've solved these well and you're ready to check your answer. So I'm going to talk through these really fast, or not too fast. So here we go. So again, we're deciding, is it log equals log, where there's logs on both sides of the equation, or is it log equals a constant? So here's our equal sign, and we got logs on both sides. So we know it's going to be log equals log, but I've got multiple logs here, so I have to start by condensing this. So you've got to condense natural log 9 minus natural log 6. So it's going to be natural log of 9 over 6, which I could simplify into natural log of 3 over 2. If I divide each by 3, just reducing. So I've got natural log 3x equals natural log of 3 over 2. So now that they're the same and they're both expressed as a single log, I can drop my logs and set the arguments equal to each other. So I'm going to set 3x equal to 3 halves. So 3x equals 3 over 2. Solve for x. So times 2. Get 6x equals 3. Divide by 3, or divide by 6. Actually, let's back that up. We should not have multiplied by 2. We should have just divided by 3 at the beginning, because we're trying to solve for x here. So divide by 3. Remember, dividing by 3 is the same thing as multiplying by 1/3. So 3's can cancel, and you're left with x equals 1/2. So x equals 1/2. Okay. Finally, we have this problem. Again, you're trying to isolate the logarithmic expression. So I've got log base 3 of 10r plus 3 that I'm trying to isolate first. Then I'm going to rewrite in exponential form, because I know this is a log on the left side of the equation with no logs anywhere else. So we know it's log equals a constant. So we got to start by isolating what's in that green rectangle there. So start by adding 2 to each side. So I've got 18 is equal to 9 times what's in the green square, or green rectangle. So we're going to now divide by 9, because again, it's not isolated fully yet. So now it's equal to 2. Now we're fully isolated. Log base 3 of our argument, 10r plus 3, equals 2. So we want to rewrite in exponential form. Isolate or identify our base, swoop it, rewrite it in exponential. So 3 to the second equals 10r plus 3, because our log, remember, our log disappears when we remove its base. And now we just simplify and solve for r. So I've got 10r plus 3 equals 9. Subtract 3. I have 10r equals 6. Divide by 10. R equals 6 over 10, or 3/5, or 0.6. And that concludes Lesson 3.3 podcast.